everyone, and welcome to another episode of Dr. Ward's Classroom. Today I'm going to be doing Gcf Factoring. This video is for my college students. Last week we did a lot of factoring, so I'll be going through each factoring that I did last week. Some of you were absent, some of you may have forgotten. I find factoring gives a lot of difficulties. Okay. Now, when they say Gcf factoring, it means the greatest common factor. So whenever I have to factor, I look at two components, my coefficients and my variables. So first I start here with my coefficients, 9 and 36, and I ask myself, what is the greatest number that would divide 9 and 36 evenly? And the answer is 9. Notice the x is only with the 9, not the 36. You can only take a variable if it's common to both terms. The x is only common with the 9, so we can't take it. So my GCF is my 9. So I'm going to take that and I'm going to put it up here. I'm going to now open parentheses. Now to get what's in the parentheses, all you have to do is perform a division for each term. That's why I draw through the fraction bar and put my GCF under. So the 9's would cancel, leaving you with x plus, and 36 divided by 9 is 4. The thing with GCF factoring is that when you distribute the 9 within the parentheses, 9 times x is 9x, and 9 times 4 is 36. Notice I got back the original algebraic expression. So all we're doing is taking our algebraic expression and breaking it up into a distribution. I have 6n to the third minus 3n to the fifth. Again, I'm going to break this up into two parts. So I'm going to start with my coefficient. I have 6 and 3. What is the greatest number that would divide 6 and 3 evenly? My answer is 3. And then notice the n's are common to both terms. But which one is my GCF? The variable with the smaller exponent is your GCF. So here, the n to the third is my GCF. So when it comes to variables, the GCF is very easy to find. Always choose the variable with the smaller exponent. So your GCF for this problem is 3n to the third. And then I'm just going to go ahead and divide to get what's inside the parentheses. 6 divided by 3 is 2. Now the n's would cancel each other out. The 3's cancel each other out. And then n to the fifth divided by n to the third is n to the second. Because remember our rules from the laws of exponents. When your bases match, you keep your base and you subtract your exponents. Here I have 8x to the third y squared plus 4x to the third. So again, I look at my coefficients. I have 8 and 4. The greatest number that would divide 8 and 4 evenly is 4. I notice that the x is only common with both terms. And I notice that they're both the same numbers. So I'm going to take x to the third. I cannot take the y because it's only common with the 8. Remember, to take a variable, it must be common to both terms. So my GCF is 4x to the third. And to get what's inside, I'm just going to do the division. 8 divided by 4 is 2. The x to the thirds cancel, leaving me with y squared. Plus, now notice here, the 4's cancel. The x to the third cancels. And what are you left with? A 1. So remember, when everything cancels, you're left with 1. I think that was a big problem on your first test. Many people were put in when everything cancels a 0. When everything cancels, it is a 1. Okay, let's get to some multivariables. So here I have 18x to the third y squared plus 24x to the fifth y. So again, I have 18 and 24, and I'm looking for the greatest number that would divide these two numbers evenly. that would be 6. I have x to the third and x to the fifth. So x is common to both terms. Remember, we take the smallest. So I'm going to take x to the third. Now, for the y's, they're common to both terms, but they're different. This is y squared, and that's y to the first power. We always take the 1 which raised to the smaller exponent. So my GCF is 6x to the third y. And again, to get the inside, just do the division here. 18 divided by 6 is 3. The x to the thirds cancel. Y squared divided by y is y, plus 24 divided by 6 is 4. X to the fifth divided by x to the third is x to the second, and the y's cancel. Now, sometimes on the test, students do not find the greatest common factor. So I always say, how do I know that I found the greatest common factor? When you look inside your parentheses, the numbers or the coefficients you have here should be only divisible by 1. If they're not divisible by 1, it means you did not find the greatest. So for example, with this example, which was 18x to the third y squared plus 24x to the fifth y, some students in class said that their GCF was 3x to the third y. And that was fine. It was a common factor, but you have to know how to correct your mistakes. So they went on and wrote 3x to the third y. And then they divided. 18 divided by 3, they got 6y plus 8. 8x squared. And as I walked around, I said, you didn't choose the greatest. And I said the reason I knew they didn't find the greatest is I looked at what was inside their parentheses and I asked them, look at this 6 and this 8. What number could divide those? And most of them said 2. So I said, okay, 2. So I put the 2 under here because we can factor out a 2. But then I told them they have to remember that when you figured out what number would then do a gradual again division, that you then have to multiply the 3x to the third y by the 2. Now the 2 and the 3 gives you that 6, like what I got when I found the greatest. So you get 3xy, and then when you divide, you get the 3y plus the 4x squared. So if you did not find the greatest, and you have to check your parentheses, 6 and 8 can also be divided by 2. Go ahead and divide by 2 to get the 3y plus 4x squared. But remember, you need to take that 2 and also multiply your GCF. So that is how you correct your error. You don't have to start the problem all over. It's just a minor correction. Such as this one, we have 36a squared b cubed plus 12ab to the third. So again, you're looking for the greatest number that would divide 36 and 12. And that would be 12. I have a squared and a, so I can factor out the a. And then I have b cubed and b cubed, so both of them are the same. So I'm just going to take b cubed. So my GCF is 12ab cubed. And to get what's in the middle, just do the division. 36 divided by 12 is 3. A squared divided by a is simply a, plus the 12 cancel, the a's cancel, and the b's cancel. When everything cancels, you're left with 1. And that's your answer. 12ab to the third, and in parentheses, 3a plus 1. Last 2 examples. So these last 2 examples is what you will see on your CEF test and departmental final. You'll be multivariables. So here I have 30x to the 5th y to the 4 z squared plus 50 y4 z5 minus 10x y4 z to the 3rd. So again, I go ahead and I ask myself, okay, what is the greatest number that would divide 30, 50, and 10? And because they all end in zeros, it's going to be 10. Now the x is common to the first term and the last term. So since it's only common to 2 terms and not all 3, I can't take x. Let's move on to y. I notice the y is common to all 3 terms, and the y is y to the 4, y to the 4, y to the 4. So I'm going to take y to the 4. And I notice the z is common to all 3 terms, z to the 2nd, z to the 5th, and z to the 3rd. Remember, we always take the variable with the smaller exponent, so z to the square is our GCF. And then over here, I'm going to write my GCF, which is 10y to the 4 z squared. And to get what's inside, I'm going to have to divide. 30 divided by 10 is 3. Okay, I'm going to keep my x to the 5th. The y to the 4's cancel and the z squareds cancel. Plus 50 divided by 10 is 5. The y4's cancel and z to the 5th divided by z to the 2nd is z to the 3rd. Take away, the 10's cancel. I'm going to keep my x because it doesn't have anyone to divide by. The y4's cancel and z to the 3rd divided by z squared is just z. So my answer is 10 y to the 4 z squared and in parentheses 3x to the 5th plus 5z to the 3rd minus xz. Okay, my last example, 20x to the 8 y squared z squared plus 15x to the 5 y to the 3rd z minus 35x to the 3rd y to the 4th z to the 5th. So again, we have to look for a common number that would divide 20, 15, and 35, and anything that ends in zeros and 5s are divisible by 5. The x is common to all 3 terms, so we will take the smallest one, so that will be x to the 3rd. Y's are common to all 3 terms, take the smallest, y to the 2nd. The z's are common to all 3, take the smaller, which will be just z. So my GCF is 5x to the 3rd y squared z. So I'm going to write that outside my parentheses. And then I'm going to divide. 20 divided by 5 is 4. X to the 8 divided by x to the 3rd is x to the 5th. The y squares cancel. Z squared divided by z is z. Plus 15 divided by 5 is 3. X to the 5th divided by x squared, x to the 2nd. Y to the 3rd divided by y to the 2nd is simply y. And the z's cancel. Take away. 35 divided by 5 is 7. X to the 3rd divided by x to the 3rd, because they match, they cancel each other. Y to the 4th divided by y squared is y to the 2nd. Z to the 5th divided by z is z to the 4th power. Again, I'm going to check my parentheses. I see I have 4, 3, and a 7. The only number that can divide those is a 1, so I know that I did choose the greatest common factor for my coefficients, and I think I'm okay. And that's my answer right here. It's big, it's long, it's nasty, but that's your answer. I hope this video has been helpful. Good luck on your exam.